Section 6.1 deals with trigonometric ratios. You've probably heard of SOHCAHTOA before to help you find the sine, cosine, and tangent of an angle. If I have a triangle, and here's angle theta, we use Greek letters. This side is opposite. This is the hypotenuse. This one's adjacent. So according to SOHCAHTOA, the sine of theta is the opposite over the hypotenuse. And the cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over adjacent. Here's the sine of theta. Opposite, go across your triangle. Adjacent, the side is touching the angle. Hypotenuse is opposite the right angle. Along with the sine, cosine, and tangent, we're going to learn about the reciprocal ratios. The cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. Remember, reciprocals are not the same thing as the inverse. Now, let's find the 6 trig ratios for the angle A. Here's A. So the sine of A is the opposite, 3, over the hypotenuse, which is 5. The cosine of A is adjacent, which is here, over the hypotenuse, and the tangent of A is 3 over 4. The reciprocal functions are the cosecant, which is the reciprocal of the sine, so it's 5 over 3. The secant of A, is 5 over 4, and the cotangent of A is 4 over 3. Use your triangle, draw the picture, and label the sides. In geometry, you learned about the special triangles and the ratios of their sides. You should remember that the 30, 60, 90 triangle, opposite of 30 is 1. The opposite 60 is root 3, and the hypotenuse is 2. On a 45, 45, 90, the sides are 1, and the hypotenuse is the square root of 2. Now your teacher might have taught you to put an A with these, or an X, or an S. Because similar triangles with the same angle measure, the sides are in proportion. I personally do not put the A, X, or S on there. I just remember them as 1, 3, and 1 square root of 3, and 2. Using our ratios for special triangles, the 30, 60, 90, we can find the sine, cosine, tangent of the 30 and the sine, cosine, and tangent of the 60-degree angle. You will be expected to memorize these and know them. They're to your benefit. So the sine of 30 degrees is 1/2. The cosine of 30 degrees is root 3 over 2. And the tangent is 1 over root 3. Or if you rationalize it, you multiply the top and bottom by root 3, you might have it as root 3 over 3. We leave the numbers exact. We do not use decimals. We do not put it in our calculator. We use the special triangle to get these ratios. The sine is the opposite, would be root 3 over 2. The cosine would be 1 over 2. And the tangent would be root 3 over 1. Again, I left them exact. I used the ratios from the triangle, and I do not want a decimal out of the calculator. You will be practicing these every day. Now, using the 45, 45, 90 triangle, we'll find the sine, cosine, and tangent for the 45 degrees. The 45 degree is 1 over root 2. Rationalize it by multiplying top and bottom by root 2, and you get root 2 over 2, which is the way I remember it. Cosine is also 1 over root 2, rationalized as root 2 over 2, and the tangent is 1 over 1, which is 1. These ratios will become very familiar with you. It doesn't really matter if you leave this as 1 over root 2 or root 2 over 2. But it does matter is whether you know them by heart, because we will not be using our calculator to get a decimal answer. Now we're going to use our knowledge of special angles and the ratios on a 30, 60, 90 and a 45, 45, 90 triangle to solve for angles. Darn it. All right, they give you a triangle, right triangle. They label this theta, this is root 2, and this is 2. And they want you to find theta. Well, we know the sine of theta is the opposite over the hypotenuse. Opposite over hypotenuse. But that triangle doesn't look like my special triangles. I know a 45 degree is labeled 1, 1, root 2. But if I multiply each side of that triangle by root 2, root 2 times root 2 becomes 2, this becomes root 2, and that's exactly like the triangle they gave me, so therefore I know theta is 45 degrees. Let's practice finding the angle one more time. Find theta. Here's your triangle. This is a right triangle. They label the sides as 2, 1, and here's theta. This is adjacent to the angle. 2 is the hypotenuse. If I have adjacent and hypotenuse, I know that's the cosine. So the cosine of theta is the adjacent, which is 1, over the hypotenuse. Now, if I think about my 30, 60, 90 triangles, this would be, the third side would be 3, would be root 3. So that makes this a 60 degree angle, so theta is 60. Now remember, on triangles, that the big side, the short side, is opposite the small angle. 30 is smaller than 60. Root 3 is bigger than 1, so root 3 is opposite the bigger angle, which is 60 degrees. The last thing we're going to learn today is how to find the area of a triangle. We know the area of a triangle is 1/2 the base times the height. Well, given this triangle here, and we want to find the area, we have 14, and that's the base. Right here would be the height. I don't know that. But I do know my trig ratios, and we know that the sine of 25 degrees is equal to h over 10, the opposite over the hypotenuse, opposite hypotenuse. If I solve this equation for h, I get h is equal to 10 times the sine of 25. So to find the area of that triangle, the area is equal to 1/2 the base, which is 14. Here's the base. The height we just found is 10 times the sine of 25. And now I'd get my calculator out and make sure it's in degree mode and find that value. And from my calculator I get 2.96 square units. And that's how you find the area of the triangle.